So if I go to my AMOS model, I have this kind of a, so if you look at the unconstrained, okay, this name is unconstrained, and you will see that there are no constraints that have been applied here. There are no constraints in this. So both this model is in the first run, this model is going to be estimated freely for both males and females. Then in model number one, look at what are the constraints. The constraints are A1 underscore 1 is equal to A1 underscore 2. So what is A1 underscore 1? This is A1 underscore 1. This is for females. And if you go to males, this is A1 underscore 2. And what is the constraint that we have applied? We have applied the constraint A1 underscore 1 is equal to A1 underscore 2. That means this factor loading now, this loading is going to be same for males and females. Similarly, A2 underscore 1 is equal to A2 underscore 2, A3, A4, A5, A6, A10, 11, 12, 13, 14, 15, right? That means what? All these factor loadings, because we said we want to test the measurement model, right? So we do this. Then we go to model number 2 now. What is model number 2? Along with these measurement weights, which was already there, you now also have the measurement. So what is a structural model? So here in structural model, structural weights, any path between latent factors. So B1 underscore 1 is equal to B1 underscore 2. This is B2. Okay, then B3, B4 and B5. I usually like to put B1 underscore 1 and B2 also in the measurement weights model. So you can actually, it is like a text editor, you can copy paste. So I cut B1 underscore 1 and B is equal to B1 underscore 2 constraint and B2 underscore 1 and B2 underscore 2. These two constraints I have cut from model 2. That means I have removed it from this constraint and I have brought it to model number 1, right? Because this is also showing measurement weights. Then if we go to model number 3, actually model number 3, 4 and 5, it does create it, but there is nothing because we had removed the text, right? So we had removed these texts. So there is nothing to be written here. Okay, so this is now analysis properties, nothing to change here, and we have removed bootstrap anyways, and we run our analysis, right? So it has now, you can see okay coming, okay, right? So we are interested in the first three models here, model the unconstrained model, model number 1 and model 2, right? Let us look at the outputs now. Okay, so just hold on with me for some time and I will try to explain what is happening in this output here. Now, if you see, you will, when you look at this output, okay, you will see here in the bottom left, okay, you are getting model names. So this is unconstrained, model 1, model 2. These are the three models that we are interested in, right? Now, unconstrained model, what is the chi-square and degrees of freedom? It is 471.941. Okay, so we can write it down in our Excel sheet. We can create a table of sorts. So we can say chi-square and df, okay, and CFI. We can say delta chi-square delta df and delta CFI. Okay, I will tell you in a while what is the importance of these. Okay. Then we have, what are the three models that we are interested in? We are interested in, first, we call it as the unconstrained. Then we have the measurement weights, and then we have the structural weights. Right? These are the three models with which we are at this time working. Okay. So for unconstrained model, this is the model unconstrained that we are looking at. So if you open it, okay, estimates, okay, you will see now that you will get estimates for females. These are the loadings, okay, and it has also given the labels. So these are the regression, right? Regression results. And you can see very clearly here what is the difference. So if you were to look at females, okay, in the unconstrained model, we see that leadership has a significant impact on procedural fairness. Okay, leadership has an impact on creative behavior, and procedural justice to creative behavior, you can see that there is no significant effect for females. Okay. If you go down, you will see the same result for males, right? So you see here the groups, okay? You can select males and you can see here what is the difference. Lead to procedural justice, the same thing. It is significant. Leadership to creative behavior and procedural justice to creative behavior, they are the same, right? So they are same, they are significant actually. They are significant, not same, but they are significant. However, for females, it is not significant, right? So if you look at for females again, model fit, okay, for females, yeah, here it shows overall model fit. So for the unconstrained, you see it shows the chi-square and degrees number of parameters is 102. Okay, so it is degrees of freedom is 318. Chi-square by df is this. For model 1, which is the, we will come to that in a while. So this was for the unconstrained model. So we have looked at, and the model fit is okay. We can see GFI, CFI, okay, and RMSEA is okay. Not so much of a problem here. Now, what we look at is, let us go to estimates. We have seen regression weights and all of this we have seen. Similarly for males, we can. Okay. Now, if you go to, what is also important to look at here in this is, in the notes, is that the degrees of freedom is 318. Okay. If you remember our overall structural model, okay, if you look at the, let me actually save it as model. Multigroup. Okay. If I go to my S model, okay, and I run the analysis here, look at what, this is what I am trying to show, that the degrees of freedom here was 159, and the distinct sample moments was 210. Now, when we do multi-group analysis, we have estimated the same model twice, one for females in the unconstrained model, one for females, one for males. So the overall for two samples, it has become 420 and the degrees of freedom has become 380, right? So this is, now if we go to multi-group, we see that our analysis has become, yes, the degree unconstrained 420 and degrees of freedom is 380. Now if we go to the model number 1, now this is where it becomes interesting. What have we said? In model number 1, we had said we will constrain all the measurement weights to be equal. That means the software will compute all these measurement weights 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. 17 it will compute for one group. Okay, it will compute only for one group. It will not compute, and it will impose the same constraint on the second group. So it will get computed only once for females group, and the same will be superimposed for the males group, right? So now if you look at, if you compare, what is the difference? 318 add 17, the degree of freedom for this model becomes 335, because there are 17 degrees of freedom that have been freed, because in second, for males, the software does not have to compute those 17 measurement weights. It will actually pick up from the females group and it will force it on the males. So now you can, using this, now what is our chi-square? 503.22. Okay, so it has become 503.22, degrees of freedom is 335. And if we look at the notes of the model fit, it will tell us. So for first one, it was 471 and 318, right? So 471 and 300.94, right? This has become our for measurement weights. Now you can look at the estimates also. Okay, this is interesting. So for look at the weights here: EMP, leadership, task orientation, and LEX 0.792, 1.178, and go to males. You will see exactly the same constraint applied on males also, because we have said that the measurement weights are the same. That means the items are behaving the same way for males and females. Similarly, look at these 1.115 and 0.929 for males, and for females also it is the same, 1.115 and 0.929. The same thing will be happening for the other groups. Now model fit, let us also report our CFI value 0.972 and 0.970. 0.972 and 0.970. Okay, so what is the delta chi-square? Let us compute the delta chi-square. It is not 500, it is 503.23. Okay, so what is the delta chi-square? It is this minus this. This is the delta chi-square. And what is the delta DF? This we anyways know it is 17. So is this significant or not? Delta CFI is how much? It is 0.002, and the p-value for chi-square, p-value for the chi-square difference test is equal to chi-square distribution right-tailed, this, comma, p7. Now, what does this show? This shows that, well, at 1% level of significance, we can say that these two models do not differ. That means if you were to apply the constraint that the measurement weights for the two models for males and female are the same, it will not make too much of a difference. At 5%, yes, but at 1% level of significance, we can say that the models do not differ. And the same thing is also concluded from this delta chi-square. We said this should be the test is this delta chi-square should be less than 0.01. If it is less than 0.01, we can say that it is, these are not different. Okay, so there is measurement invariance. So we can say that measurement weights are the same. There is no difference in the model. If you were to, you can actually dig down deeper in this. You can go and change now specific constraints. So you can remove just one and then let all other constraints remain. Okay, and then you can check if I allow A2 to change or A1 to change between males and females and keep all others constrained, whether I will get a good model fit or not, right? Then you can check A2, then you can check A3, and you can do it for each one of your measurement weights and check whether they differ between the two groups or not, right? And so you can free, if there is a particular weight which actually is changing between the two groups, okay, because of which the models are differing, then you can actually change it and run it and test it again with the model. So you can even do, so instead of doing all of these together, you can actually just retain or remove one, okay, and test with all other, and then check if I were to allow A1 to move freely between males and females, will this model give me a good fit? Else I go back and then I change A2 and drop it and then check what is happening between the two groups and so on. So here I'm going to go ahead with the conclusion that, well, we can consider the two groups to be the same. So I'm going to go to the third group or the third model, which is the important model that I want to look at, which is now my, okay, so now the unconstrained model, this was the fit, the model 1, this was the fit, and model 2, I see that there is one more degree of freedom that has been freed up in the, because we had said in the third model number 2, we had added 3 more paths, okay, so whereas in this model, model number 1, we had two constraints. Here, instead of B1 and B2, actually we should have retained B1 and B2 also here. and then I would have got the same constraint. Okay, so I should have retained B1, B2 because I am constraining all the measurement weights, and along with the measurement weights, I also want to constrain my structural paths. So I will just run this again in order to test my. Okay, so for unconstrained and model 1, the fit will not change. It is the same that we had got. And now for model number 2, you will see that your degrees of freedom has increased by 3. Why has it increased by 3? Because we have constrained 3 more paths. And what are these paths? The structural path between lead to PJ, path between lead to CB, and the path between PJ to CB. So it has to estimate these 3 paths only for females, and it will apply the same weights to the males model. What are the estimates? We can see it is 0.521, then 0.170 and 0.108 for females. And you can look at the same thing for males. It is exactly the same for males also. 0.521, 0.170 and 0.108. So the same constraints are, so the model is saying, what we are saying is that the paths will actually be the same for both males and females. The relationships will be the same for both males and females. Let us check whether this model is actually significant or not. So if we look at 512.208, so let us write it here, 512.208 or 0.21, and this is 338. And what is CFI? CFI is 0.969. So what is the delta chi-square? Minus compared to the unconstrained model. And what is the degree of freedom? It is going to be 20. What is the p-value? This p. Okay, now, and what is the so our CFI is actually telling us that it is not different, okay, because it is still less than 0.01. But our chi-square test, if you see, chi-square test is telling us that, well, this model is actually different from the unconstrained model. That means you need to now apply, we need to actually check if you are constraining these 3 paths, well, it is actually showing that these models are not the same. So you need to actually check which path should actually be unconstrained and which I can keep them as constrained in order to check whether we can have it, the model fit improves or not. So what do we do now? I will show you one more iteration that we can perform to actually check which path can actually be left free and which path can be constrained to be equal for both males and females. So what do? You actually go to in the unconstrained model, we know from the results, okay, we know from the results that for females, procedural justice to creative behavior was non-significant. But for males, it was significant. Right? So is this path the path that is actually creating the problem? So what do? We actually go to our model 2 and we copy all these constraints. Okay. So procedural justice to creative behavior is path 5, and I go to model number 3 and I paste all of this, but I remove the constraint B5, okay, on path B5, and I remove this constraint that B5 underscore 1 is equal to B5 underscore 2, because I want to check if I allow this path to vary, but I keep the other two to be the same, will my model show that these are same models? Okay, so I will close. Okay, so now I have my model 3 where I have only measurement and structural parts, but B5 is not there. And then I will run it again. And I go to my estimates and I go to the model fit. Okay, and I look at model number 3 now. Model number 3 is giving me a chi-square of 507.762. So 507.76, and the degree of freedom is 337. Okay, the CFI is 0.969, that does not change. So what is the delta chi-square? Minus the unconstrained model. And what is the degree of freedom? Is 19. So now if I do my chi-square distribution test, this gonna be 9, I get, again it goes above 0.01. This remains the same, 0.969 minus, sorry, this minus. Okay, so now what we can say structural weights are also constrained, but Pj to Cb free. So what is our conclusion? So we can say that these models are actually the same as constraint. What does this mean? It means that males and females behave or look at these items and look at these constructs the same way, the relationships between them the same way, except for Pj to Cb. And this is the evidence, okay, that if I constrain these paths, okay, I constrain Pj to Cb also, then I get a significant difference between the unconstrained and this model. But if I let this path to be free, then this is, and constrain everything else, it does not actually change from the unconstrained model. So everything can remain the same, but Pj to Cb path is different between the two groups. Right, so this is how you can use multi-group analysis to actually check your uh, to actually also see how you can vary, or how do these relationships vary between different groups.